Hello and welcome to the Mother Earth News Online Homesteading Summit. This is Marjorie Wildcraft, your host. Our next presentation is in the intermediate to advanced category, and it's going to deal with micronutrients and soil microbiology to improve your crop production and taste. Yummy. Dan Kittredge has been involved in the organic movement for over 30 years. He was the India County Coordinator for the Global Anti-GMO Campaign. He's the executive director for the Remineralize the Earth group. He founded the Real Food Campaign, and he is the executive director of the Bionutrient Food Association. Dan's pretty busy. Dan also has a year-round farm in North Brookfield, Massachusetts, where he grows vegetables and pastured poultry and beef, utilizing the biological management practices that he helped create. So here's Dan Kittredge. I also at the end want to discuss a bit about a really amazing new device that Dan is working on to develop.
My name's Dan Kittredge. I'll be talking today about soil quality and plant health and human health and some really interesting connections between them all. I like to call this talk Principles of Biological Systems, how living systems work. My thought is that the more well we understand how nature evolved things, the more well we can get in line with it. So before I get started on the talk, just a quick minute about myself. I am a farmer. I grew up on an organic farm in 1980s in central Massachusetts. My parents bought a 30-acre piece of land, a couple fields, and some forest, and built a passive solar house with a root cellar and a wood stove that was our hot water and heat and cooking. We had, I think we were certified organic in 1986. We started our CSA in 1991. We did mixed vegetables. We had an orchard. Animals, pigs, cows, chickens, ducks, geese, turkeys, sheep, etc. A nice full homestead. And I spent my childhood in that milieu, working on the farm, and then my 20s working on managing the farm in the summertime and traveling in the wintertime until I got married 12 years ago, at which point I had to come to terms with the fact that I was not what I thought of as a very successful farmer. I did a lot of work and didn't make much money, and thought maybe that if I didn't want to be doing that for the next 50 years, I could think about some ways of doing a better job. I had always thought that organic was a superior sort of methodology, but when I got really down to thinking about it, I understood that nature was telling me that I was not doing a good job. And this is part of the conversation today, is the the variation, the spectrum of variation, high quality organic and low quality organic, high quality local, low quality local, et cetera, et cetera. There's a variation within all of our labels, and learning to discern the difference and act accordingly, I think, is potentially one of the most powerful things that any of us can do for the world at large. And hopefully you'll agree with me by the end of this presentation. So, not to belabor the point, but when I was about, I think I was in my mid 20s, and we had our old farm dog Stewball on my parents' farm. He was old at that point in time, and he had been laying on the driveway when a CSA person drove in and didn't see him and drove over his hind end, and he yelped, and they stopped and came out, and he was able to stay in the house for the next couple of days while he was recuperating. But when he was back outside a couple of days later, I was checking him. I noticed that there were some maggots that were eating his hind end where the flesh was still, where the skin was still hadn't healed. And I was totally repulsed by this sight of maggots eating my dog. And I was on the way out to pick potato bugs off of my potato plants. I had a 5-gallon bucket in my hand, and I was going to knock Colorado potato beetle larvae into the bucket. Otherwise, they would eat those plants alive. And something clicked for me when I realized that it was totally normal for insects to be eating my plants alive, and I didn't think anything of it. But it was totally repugnant for insects to be eating my animal alive, and I thought maybe that there was a sign here, a symptom here, a larger lesson. And as I've come to understand, I think that there is actually a lot there. I like to use the example of a flesh-eating fungus. If any of you has children or dogs or cats or animals, if one of them had a flesh-eating fungus, you would probably be very concerned. And if it was a chicken or a cow, you would, I'm certain, not feel that the appropriate thing to do would be to slaughter that animal and feed it to your children or to sell it. And yet, when you have tomatoes with a blight or squash with a mildew, that's a flesh-eating fungus. That's a symptom of a really sick plant. And so what I've learned over my years of delving into these principles of biological systems is that the more healthy your plants are, the more nutritious they are, the more flavorful they are, the more pest and disease resistant they are. Actually, you have better yields. There's a virtuous circle at work here when life is flourishing, and so that's something I want to be spending some time talking about. I like to start the talk with just a quick overview of how plants grow. We notice that in fact, most plants have green leaves, whether they're trees or grass or vegetables or herbs. They all cover themselves in green, and we know that they do that because it's the chlorophyll and the chloroplast that is where this magical process of carbon dioxide and water and sunlight being converted into sugar and oxygen occurs. And it's a very important process for the plant. It's a foundational place where it builds energy. We know that the oxygen that's manufactured in that reaction is emitted out into the atmosphere, and that's what we breathe. What we don't know in many cases, many people don't know, is that a healthy plant will take a majority of the sugar that it manufactures in those leaves and inject it into the soil. So plants cover themselves in green to make sugar and oxygen, and they put the oxygen into the atmosphere, and then they put the sugar into the soil. So what's the deal? Why would plants do this? I feel like this is an important piece to understand when it comes to understanding how to grow healthy plants. The reason that plants do that is because in nature, before farmers started tending plants and managing plants, plants had the ability to feed themselves without anyone adding fertilizer or compost or chicken manure or blood meal or bone meal or whatever all of the different things are that farmers add to the soil that they call fertilizer. Before there were farmers, plants were able to feed themselves, and still plants in nature feed themselves without fertilizer. And the way they do this is that they take the sugar that they manufacture in their leaves and inject it into the soil to feed the life in the soil, the bacteria and fungi in the soil, because it's the bacteria and the fungi that have the ability to exude the acids and bases, to solubilize the soil, to harvest from the soil those nutrients which the plant needs to grow. The phosphorus is taken up by the mycorrhizal fungi. The azotobacter and rhizobacters are harvesting nitrogen from the atmosphere. There's all kinds of different species of bacteria and fungi that have the capacity to effectively harvest different nutrients and feed them to the plant. That's how plants have evolved to grow. And as a farmer, I consider it good practice to help create that environment where the soil life is flourishing and therefore the plant is being fed. I like to use the example of the Grand Banks, which is a fishery off the coast of New England. Let's say all the fishermen from Newfoundland to New Jersey drive their boats to the same spot in the ocean and park there to go fishing. And the reason that they all take their boats and park in the same spot to go fishing is because that's where the fish are. And they're not in other places, they're there. And they're there because their food is there. And their food is there because its food is there, basically. Only where the bottom of the food chain, only where the phytoplankton flourish, does the rest of the food chain flourish, all the way up to the fish that we catch and eat. And the reason that the phytoplankton exists in that environment and not in other environments is because it has the right mixture of sunlight and warmth and minerals for them to exist. So in the same way, only when the bottom of the food chain, the bacteria and the fungi in the soil are flourishing, should we expect the top of the food chain, our plants and ourselves, to flourish. So really, when it comes to growing plants, I like to think about what is the environment that the life in the soil needs to flourish, and are we doing a good job creating that environment or managing for that environment as farmers or gardeners or homesteaders or however you identify. Many of these principles are extremely simple and very self-evident, and it should be easy for you to identify where you are missing pieces in your management practice, and hopefully this will be a productive, valuable lecture that you can apply after listening. So what does life in the soil need to flourish? I like to start with air. Life needs air to breathe. We're all very familiar with this concept. If we've got children or animals, they need air to breathe. Well, many of those symbiotes, those people in the soil, the bacteria and the fungi that are feeding the plant, are aerobes, which means they need oxygen to breathe. So one very simple thing you can do is take your hand and try to stick it into the soil and see how far down it goes before it starts to get underneath your fingernails and feel uncomfortable. Can you go down a half an inch, inch and a half, 3 inches, 6 inches, a foot and a half? How far down can you reach your hand into your soil? Up to the elbow, up to the shoulder. Some farmers can reach their arms down up to the shoulder into their soil. Many farmers can go down about a half an inch before it starts to get driven underneath their fingernails. As far down as you can reach your hand into the soil, I like to say, is as far down as you should feel comfortable that there is sufficient air for life to breathe. So if you can only reach your hand down 2 inches before the soil gets very tight and compact, then understand that below that area, life is unable to breathe, and so therefore is not flourishing, and therefore is not feeding your plants. Some simple things you can do to maintain aeration in your soil. One really simple, really important one is keeping the soil covered. I like to say, where in nature do you find bare soil? And sometimes people will say, in the desert, to which I respond, and how well is nature doing in the desert? Is she flourishing in the desert? Likely not. Where you see nature flourishing, you don't see soil. Nature really thinks it's important to keep herself covered. And so when we are managing our farms and gardens in such a manner as to have soil be bare through much of the growing season, we're actually being very counterproductive to nature and harming her. Some people may have had the experience of having a bare soil garden bed going into the winter. In late fall, the soil is bare, and maybe in one spot there's a pile of leaves or a pile of old hay or something like that. What I've seen in that kind of an environment is that after the winter is past, in April when the snow is melted, the area where the soil was bare in the fall is now very hard and very tight, and oftentimes it'll be cracked. But the area where the soil was covered with mulch, the soil is very loose. If you pull back the mulch, you'll find it's loose and friable. It's covered with earthworm castings. You can reach your hand down inches very easily. Oftentimes it has a really nice smell. And the only thing that was different between that hard, tight soil and the loose, aromatic soil is that it was covered. We understand that the plants are making sugar in their leaves, which they feed down into the soil to feed the soil life. Well, when there's no green plants making sugar in the middle of the winter, and the soil life haven't moved out, they didn't go to Florida, they still need to eat. Where's their root cellar? Where's their canned tomatoes? Where's their freezer full of meat? Where is the food that they have to eat? In this case, the dead plant material, leaves or straw or hay, would be that food for the soil life, which will keep it alive, which will mean that you've got a good level of life present in the soil when you put your seeds or seedlings in the spring. Similarly, in many cases, farmers will do this bare cultivation strategy where they have lots of bare soil, and in the growing season, in the heat of the summer, you'll find very little life, very few earthworms, very a soil that does not have a strong aroma because it's not being fed. So soil needs air. Life needs air to breathe. It needs food, the organic matter, the mulch, the flourishing green leaves. These are key pieces of the puzzle to be looking at and managing for through the growing season. What else does life need? Life needs water to drink. We all know this. Life needs water to drink. But in many cases, if you reach out down into your soil and pick up a handful of soil, you'll find that it does not hold together. If you squish it, it does not feel moist. In many cases, when people are watering their gardens or their fields, they'll water around the base of the plant, but they don't think about the fact that there should be as big a root system as top growth. The plant should be as big underground as above ground and as broad. And really, it's the area at the edge of the roots where the soil life is working, where the plant is being fed. And if the only place you're watering is right at the base of the plant and it's dry out, you should not expect the life to be alive and flourishing far beyond that one small point. That will oftentimes cause imbalance in the plant. This effectively a root system that's too small to support the top. So on my farm, I consider it a very high priority to keep the soil moist across the entire soil profile. I personally use drip tape. I'm not, I don't have a preference for one form of irrigation system or another, but here in Massachusetts this year, we had a extreme drought, and irrigation, those farmers who didn't have sufficient irrigation really lost their shirts. I would suggest that with climate irregularities becoming more and more regular, having the capacity to maintain hydration through the entire growing season is a very critical piece of the puzzle. You'll notice that even while crop fields may suffer in a drought, grasslands and forests do not suffer so much. In many cases, that's because they have a deeper root system, and also because the soil is not tight underneath them. There's a area called the plow pan, which is the point right below where the plow cuts the soil, or where the tiller tines till, where the soil is oftentimes very tight. It can be tested with a penetrometer, and that tight soil will not allow water to percolate freely through it. In nature, we have this process called the tidal force, where the tides in the ocean, the shore, go up and down twice a day based on the gravitational pull of the moon. As I understand it, that gravitational pull of the moon is not just operational in the ocean; it's also operational on land. And if you don't have a plow pan, if you have a good structure in your soil that isn't tight at any region, then your plants will actually be watered from below twice a day, as through capillary action, the water from the water table moves up through the soil into the root zone to water your plants. So there's many ways to think about water and watering and maintaining hydration, but it is certainly an absolutely central piece of the puzzle. If you want to have healthy plants, you must have moisture in the soil for your soil life to live. So and the next piece of the puzzle perhaps I could talk about is the life in the soil itself. We understand that there's millions of different species of bacteria and fungi, all with their different faculties and skills and capacities. Some are copper solubilizers, some are zinc solubilizers, some are good at tying up heavy metals, making them inert. Others are really good at digesting toxic compounds, eating radioactive isotopes. soil life is really quite an amazing story, one poorly told. But ensuring the broadest spectrum of species in the root zone of your plants is an extremely important and oftentimes one of the most simple, easy, inexpensive things you can do to dramatically improve the function of your growing plants. I like to use the metaphor of colostrum in this case. We know that when we humans are born, there are no people living in our alimentary canal. And by people, I'm referring to bacteria and fungi. There's no other organisms between our mouth and our rear end. And we also know that we are unable to digest our food. It's those organisms that live within us that digest our food for us in the same way that the soil life digests for the plant. The plant is unable to digest the soil. The plant is unable to exude the acids and bases and solubilize the nutrients it needs. It needs the bacteria and fungi to do that job for it, as we need our gut flora to digest our food for us. And so the act of passing through the birth canal and will help to establish the flora on our skin, and the colostrum, which is what comes out of the mother's breast after birth before milk, is what is we have evolved with to establish the flora in our gut. Without a good, healthy gut flora, we can't digest our food. If you have a baby cow that doesn't get its colostrum, it'll bawl and bawl and bawl for days until it dies, likely, because the baby cow is unable to digest its food. And a human case, that would be called a colicky baby, a baby that is in pain and cries and doesn't sleep well. It does not have a well-established gut flora. Well, think about your plants as either as colicky babies. Those plants that don't get their gut flora established at birth well, don't get their colostrum at birth, are weak and sickly and susceptible to disease, and they don't flourish as well. Well, establishing that gut flora, inoculating, is a very, very simple process. If you purchase an ounce of spores, a broad spectrum of 35 or 40 different families of bacterial spores, and maybe 15 or 20 different families of fungal spores, 1 ounce might cost you $5 and be good for 50 pounds of seed. It's a really, really simple, really, really inexpensive. You just take a pinch out of that packet and put it in every seed packet you've got. And when you plant those seeds, as they germinate, those spores will germinate also, and they'll be able to set up that symbiotic relationship at birth for the plant. So inoculation is a very powerful, very simple piece of the puzzle, not often discussed, as is my final topic, minerals. Minerals is something I had really not heard anything about growing up on an organic farm and being part of the organic community. I had some rudimentary knowledge of limestone and pH and NP and K, nitrogen, potassium, and phosphorus, but the broader spectrum of elements necessary for life to flourish was something I was thoroughly unaware of. As I began to research and find things out, I came across information that said that even just basic ground up rock, granite, and basalt would be actually potentially be very valuable for my soil. And so I thought I would do an experiment. I went to a quarry and got a bunch of their granite dust and went and spread it on a field of broccoli and cabbage, a fall planting of broccoli and cabbage. And the improvement in the vigor and the sheen and the vitality in those brassicas over what was normal was quite pronounced. And subsequently, I've done much more research and experimentation and practicing, but looking into the science behind all this. I think remineralizing, addressing underlying nutrient deficiencies in the soil beyond nitrogen, potassium, and phosphorus, looking at some of the trace elements like copper and zinc and manganese and cobalt and boron, can really be quite powerful when it comes to increasing overall system function. I like to use the example of vitamin B12 when talking about minerals. Anybody who's been a vegetarian may have been told by their doctor that they need to supplement their diet with vitamin B12 because they don't get enough of it in their plant-based diet. And Vitamin B12 is the common name for a compound in science referred to as cyanocobalamin, which is basically one atom of cobalt with a few amino acids attached to it. So it's not the amino acids that are the limiting factor, it's the cobalt itself. So we can say that when you don't get enough B12, you become anemic or lethargic or weak. And if you really don't get enough B12, you become dead. We as humans need a certain amount of B12 in our body. We are B12 dependent organisms. We're actually cobalt dependent organisms. What's interesting about that is that about 80% of the species of soil life that have been so far studied are also B12 dependent. 80% of the species of bacteria and fungi that are the symbiotes of our crop plants also require B12, which means they need to have a certain level of cobalt in the soil for them to exist and to flourish. Cobalt is just one of many elements, dozens of elements that are actually very important for life to flourish, and which in many cases growers are not attending to when it comes to managing their soils. So we always recommend through the BFA, or the Bionutrient Food Association, a broad spectrum soil test, generally an Albrecht style soil test, that looks at least 16 or 18 different elements and helps farmers identify which deficiencies are present and at what level amendments are necessary. So this is a much broader conversation. I think, perhaps just to drive the point home, I'll talk a little bit about history and agriculture. We have, in Western history, we talk about agriculture starting 10,000 or 12,000 years ago in the Fertile Crescent in Mesopotamia, in the Tigris and Euphrates River Valley. I like to look at what cultures have been able to perform agriculture in the same spot for thousands of years. And we have many examples of cultures that have risen and fallen, and their soils wore out and are now desert in many cases. But where has agriculture been able to be practiced for thousands of years continuously, and what's going on there, and how are they able to maintain those soils? Because in many cases we see soils that are beginning to weather and weaken and wear out. Some good examples of cultures that have been able to do that are still in Mesopotamia, in the Tigris and Euphrates River Valley. They've been doing agriculture there for thousands of years. In Egypt, in the Nile River Valley, agriculture has been performed for thousands of years continuously. In the Ganges River Valley, the Indians have been doing agriculture for thousands of years, a major agricultural civilization. And in the Yellow and Yangtze River Valleys as well in China, we've got major agricultural civilizations that have been maintaining themselves for thousands of years. And what these civilizations, agricultural civilizations, all have in common is that they're in river valleys. So what's going on? Why is agriculture able to be performed in river valleys for thousands of years and not in other areas? I'll use the example of the Nile. The Nile, there's the Blue Nile and the White Nile. The Blue Nile comes out of the Congo, which is a tropical rainforest similar to the Amazon. This amazing, fecund, just vital, vibrant ecosystem, and all the life and the organic matter in that, from that ecosystem comes through the Blue Nile. The White Nile comes out of the mountains of Ethiopia. The glaciers in the mountains are grinding up the rock, and it's the glacial milk, the ground up rock powder that causes the White Nile to be called the White Nile. So when you mix the White Nile and the Blue Nile, you mix the ground up rock minerals and the organic matter and life together and deposit that on the soil. You basically have there a pretty full spectrum fertility program. When you're practicing agriculture and you're harvesting fruits and seeds and things, what the plant has been doing in building its fruit or building its seed is isolating the most valuable nutrients for its babies for next year. And when you go in and you harvest those all out, you're functionally, year after year, decade after decade, century after century, removing some of those critical elements from the system. And what happens when they begin to become in short supply is that life no longer functions in that environment. And I think in many cases we have gardeners and farmers who are struggling to help their plants flourish, and these underlying mineral deficiency issues are systemic. Just to talk about how that works a little bit, and maybe go into some of the connections as it pertains to human health and maybe pest and disease resistance before we conclude. I like to use the example of a hoop house to explain this piece. A hoop house is for those who are not familiar, a greenhouse is a large structure, oftentimes metal, covered with glass. A hoop house is a large structure, oftentimes metal, more round than angular, oftentimes covered with one big sheet of flexible plastic. On my farm, we have 8 hoop houses, about a half an acre of hoop houses. We do a lot of fall and winter and spring salad greens. It's a significant part of our cash flow for the farm. But what that means is that I'm very conversant with building hoop houses. So I'm going to use the process of building a hoop house to make a point. When you start building a hoop house, you've got a pile of metal pipes that's maybe 10 or 12 feet long and say 3 feet wide, 2 feet tall. It's a pile of metal pipes. It's not really that impressive, but it's a pile. And when you get done building that hoop house, that pile of pipes has turned into a structure that's 100 feet long and 30 feet wide and 15 feet tall. And interestingly, the process of taking those pipes and putting them together required only the use of a 9/16 and a half-inch socket and wrench over and over again to tighten the nuts on the bolts to hold the pieces together. So this is the process of using this tool with this unique size and shape over and over again to put something together, or you could actually use the same tool to take it apart, is very akin to what enzymes do in biological systems and living systems. And this is where it gets kind of exciting. All of our to build a carbohydrate out of a simple sugar requires an enzyme to screw all those sugars together to build this carbohydrate structure. Building a protein out of amino acids requires an enzyme to screw those pieces of amino acid together to build the protein, etc. All of our hormonal and glandular biochemical systems require these different enzymes to function. And what gives each enzyme its unique size and shape to do different jobs are the elements at their core. Different elements, copper or zinc, have a different size. Like, say, copper would be 1.5 angstroms across, and maybe have a bonding geometry that's 8-sided or 6-sided, and maybe zinc is 1.6 angstroms across and has a 10-sided bonding geometry. Either way, it's the element at the core that gives the enzyme its unique attributes, and without that element, you don't have the enzyme and you don't have the ability to build that compound. So I like to talk about, if you were a car and your brake pads wore out, you're designed to have your old brake pads taken out and new brake pads put in. If you are a car and your muffler wears out, your muffler's designed to be taken out and a new muffler put in. That's a machine. Machines have these interchangeable parts which are designed to be taken out and replaced. And we are not machines. We are living systems, and we have been designed to function in a different manner. As I understand it, we get about 4 billion new cells every day. Every day, 4 billion of your oldest, most worn-out cells are disassembled, and whatever pieces can be salvaged and used are kept, and the rest are shunted out the rear end. So if you do the math on how many cells we have in our body and how many cells we get new every day, on average you get a new body roughly every 6 months or so. Certainly the bones take years to replace themselves, and the blood may only take weeks to replace itself. But functionally, our bodies are constantly being rebuilt. Your eyeballs, your liver, your toes, your bones, your flesh, everything is constantly in a state of being rebuilt. If you think about that a little bit deeper, inside of every cell is a nucleus. Inside every nucleus is DNA. And DNA is actually a very large compound. I think most people are familiar with that. When the Human Genome Project was being performed in the 1990s, the scientists not only identified all the different pieces of the DNA, but they also identified the enzymes necessary to replicate the DNA. And when they had figured out the enzymes, they were able to identify all the elements at the core of those enzymes. Interestingly, there are dozens of different elements required to replicate every one strand of human DNA. Copper, zinc, manganese, boron, cobalt, vanadium, molybdenum, selenium. Keep going for a while. Yttrium. Probably more elements than many of us can name are used 4 billion times a day to do our basic replication process of bodily maintenance. That's not talking about our hormonal and glandular systems. That's not talking about all the rest of our systems. We need more than 24 different elements every day in our body for basic functionality. And the point here is an important one, because when you take a soil test and you send it off to your local university lab, oftentimes you'll find a recommendation coming back for 3 elements: nitrogen, potassium, and phosphorus, and perhaps calcium or sulfur, depending on your pH. But agronomy does not look at crops as food per se. When farmers sell their crops based on their volume or weight and aesthetic, how much of it there is and how it looks, but not actually how nutritious it is. So this is the key point about our animal instinct, food quality, flavor, aroma, nutrition, human health. There's a really interesting and powerful conversation here that needs to be had, we suggest, around these questions. As the plant has access to more of these different elements and nutrients, it is able to build more and more complex compounds within it. It's able to build carbohydrates out of sugars. It's able to build proteins out of amino acids. It's able to build fats and oils, lipids. It's able to build what we call plant secondary metabolites. There's carotenoids and terpenoids and phenolics and all kinds of fancy long science-sounding words that correlate with what we call flavor and aroma. When a tomato that you buy in the grocery store doesn't have much flavor, it also doesn't have many of those big, fancy-sounding compounds in it. It actually has less nutrition. It's actually less good for you. When you pick a ripe tomato off the vine in your garden and it has an exquisite tomato flavor, you know you are getting more nutrition from that tomato than from the one from the grocery store. I like to use the example of a peach because I don't think I've ever found a peach in a grocery store that resembled what my experience has been of a peach picked ripe off of a tree. There's a large spectrum of variation in our flavor and aroma experience, which correlates with the nutrition experience of the body. And so this is why we are advocating for a greater attention to the question of how crops taste and smell and how nutritive they are, as opposed to whether they're referred to as or marketed as local or organic or biodynamic or whatever other label may be associated with them. We have organic crops with no flavor or poor flavor, and organic crops with high flavor. We've got local crops with poor flavor and local crops with high flavor. It's the nutrition in the crop which determines its value, not the label associated with it. If you have an environment in your cell as it's being replicated where an element is missing, say chromium, In that DNA, the two pieces of DNA that are supposed to be put together by the chromium-based enzyme are then unable to be put together because the chromium's not there, because it wasn't in the food, because the farmers weren't attending to elements like it, like chromium. Then those pieces of DNA don't get put together. It's a break in the DNA, referred to as a genetic marker. We have successfully identified numerous genetic markers associated with various degenerative diseases. And what's exciting is that these genetic markers are not something that we need to consider to be a permanent situation. If you understand that you get a new body every 6 months, then you understand that what you eat now will determine how well your body rebuilds itself. And through changing your diet, through improving the quality of the food that you eat, you can literally fix these genetic markers. We have major fiscal turmoil around maintaining healthcare costs or paying healthcare costs in this country. Much of it for what are referred to as degenerative diseases. Degenerative diseases are diseases that are managed but not actually cured. Diabetes is managed, heart disease is managed, osteoporosis is managed, cancers are managed. Many of these diseases are not curable per se. We have strategies for managing them in medical science. And yet, if you look back to the founder of Western medicine, Hippocrates, his first dictum was, first do no harm, and then let food be thy medicine. We understand that good food that's nutritious and aromatic actually has the capacity to heal because it has these nutrients in it, as is defined by the flavor and the aroma. And this is where our animal instinct comes in. We are actually still animals, and we do actually have instinct. Apparently, 30% of our DNA is associated or involved in the function of our nose and tongue. Nature seems to think it's really important that we're able to discern in a very exquisite manner nuances in flavor and aroma because they actually correlate with unique elements and nutrients and whatever imbalances we may be experiencing based on our previous what we've eaten earlier. So it's a very exciting topic. There's a really nice correlation between food quality and flavor and aroma and plant health and soil health. And maybe just to conclude, understand that when a healthy plant is making sugar and injecting it into the soil, functionally, among other things, what it's doing is taking carbon out of the atmosphere. The carbon dioxide is used to make sugar along with water and sunlight, and injecting it into the soil. So it's actually carbon sequestration. We have good documentation of fairly large-scale farms, thousands of acres farms that are not composting or mulching, but are increasing organic matter levels by as much as 0.5% per year, from 1.5 to 2, from 2 to 2.5, etc. And they're doing that simply through growing healthy plants. Those healthy plants are taking carbon out of the atmosphere and putting it into the soil. If you were to look at agriculture on a planetary scale and do the math on how many acres of agricultural land there are, and imagine that all of that agricultural land was being managed well, plants were being grown in a healthy manner, the amount of carbon that could be sequestered through agriculture per year is so large that it would only take us about 3.5 or 4 years to sequester all the carbon that's been put into the atmosphere since 1750, to go from 400 ppm CO2 now to 280 where it was 250 years ago. It's quite exciting, and we can do that through agriculture practiced well. Those compounds that are in plants that correlate with flavor and aroma, as I said, are fairly large compounds and somewhat difficult to digest for simpler organisms. Just to explain this point, this is a discussion of pest and disease resistance. I like to use the example of a cow and a bale of hay, and say that there was a bale of hay in a room, and when you walked in, you might have considered sitting on it, but you probably wouldn't have considered eating it. If a cow walked in, she would see that bale of hay not as a seat, but as food. It's food for a cow because she's got 4 stomachs and has the capacity to digest straw and hay into usable energy, and we don't. She has a more sophisticated digestive system than we do. If you understand that concept, understand that the larval forms of insects don't have a liver as we do. They don't have in their gut the enzymes necessary to break down protein. And so if the plant that you're growing in your garden or on your farm is able to build protein on the way to building lipids, on the way to building the secondary metabolites, on the way to being flavorful and aromatic, it actually becomes indigestible to those insects, those larvae. We don't need to go into all the complicated biochemistry, but that is applicable for the soil-borne pathogens, the Alternaria, Rhizoctonia, Pythium, Verticillium. These, have a fairly simple digestive tract, and when the plant is building compounds, because it's healthy, that it becomes indigestible for these pathogens. As with insects, then with the fungal diseases, the blights and the mildews. As the plant becomes healthier, as it has a more well-functioning digestive system, as it's able to access all the nutrients it needs to flourish, it becomes literally indigestible to pests and diseases. I like to say that this is nature's report card. If you have bacteria eating your crops, then you are growing bacteria food. If you have insects eating your crops, you are growing insect food. If you've got fungus eating your crops, you're growing fungus food. And only when you've got animals eating your crops are you growing animal food. Only when your crops are flavorful and aromatic to your senses do they have the nutrition in them that makes them indigestible to these other insects and bacteria and fungi. It also makes it nutritious and flavorful for you. So this has been my experience as a farmer, is that my levels of pest and disease pressure have dropped off dramatically, except for the animal pests, which are now a fairly significant issue on my farm. So something to be concerned about perhaps, but a symptom of success in this regard. So as I was saying, as the plant becomes healthier, it becomes indigestible to pests and diseases. Well, crops that are indigestible to fungus don't need fungicide. Crops that are indigestible to insects don't need insecticide. If you are growing crops on a large scale that don't need these products, then the implications for agribusiness are actually quite exciting, and the ecosystem. If you are growing plants that are able to digest the soil and the atmosphere around them through help from the bacteria and fungi, then you actually don't need fertilizer. You don't need the nitrogen fertilizer. You don't need the potassium, phosphorus fertilizers. So think about all of the aquifers and the pollutants in the environments from agriculture. If we had crops being grown well, we would not have these issues. Think about the political power that agribusiness has based on the fact that farmers buy their products. Imagine if we were growing healthy plants, we wouldn't be putting this money into agribusiness. They might not have the power. We might be able to actually have a real conversation about a farm bill. I like to talk about the human health and pharmaceutical industry and medical device industry and the bankrupting of the federal budget deficit is also can be considered in this regard. We, as an organization, the Bionutrient Food Association, have a mission and an objective to increase quality in the food supply. We're increasing flavor and aroma, and we think that by doing that, by increasing quality in the food supply, we can help achieve these many different systemic solution-oriented effects. and our we do work with growers. We do lectures and courses. We have local chapters around the country. We've got mineral depots. We have agronomy conference calls and support recommendations. We've got a wonderful annual conference coming up in December with great speakers on all kinds of different aspects of this topic. And we're working to build a tool that a consumer can use, similar in size and price to a smartphone, that you literally could go to the grocery store and flash a light, like a smartphone camera flash, and based on the light that bounces back, read the nutrient level in the crops. This is may take a couple of years, but it's a thoroughly viable and plausible strategy to give the consumer the ability to test crop quality at point of purchase and make purchasing decisions based on that. We understand that that money is power in today's day and age, and I suggest that most people eat food, and most of those people who eat food actually buy food. They use money to buy food, and so if we can help organize consumers' purchasing around their own self-interest, their health, their children's health, help them choose the most flavorful and aromatic food, that will actually directly support carbon sequestration. It'll directly weaken agribusiness. It'll directly improve the ecosystem. It'll directly improve their health. We suggest this is a very powerful potential for the food movement to collaborate upon, whether you're a permaculturalist or a slow fooder or a Western pricer or organic person, whatever your allegiance is or however you self-identify, we all really are looking at food quality and flavor and aroma and health-giving attributes. So that's a major piece of the work moving forward with the Bionutrient Food Association. You come check out our website, attend our conference, contact us if you'd like us to come and speak in your local area or host a 2-day course for deeper implementation of these practices. Thank you.
So that was Dan Kittredge. If you want to reach him at the Bionutrient Food Organization, just click on that button to the right there. They have a conference every year where they bring a whole bevy of experts in that, again, I would say this is more of an intermediate to advanced level of topics. What excited me when I talked to Dan about this presentation is he is working to develop a small handheld device that you could just use it when you're shopping in the grocery store to determine the nutrient density or quality of the produce that you're about to buy. So you pick up some tomatoes, you scan this device, and you would know, hey, this has really got a lot of minerals in it, or you'd know, hey, this is basically red cardboard. I know that he's got the device in development. He says that they're needing a couple of $1 million more for the funding of it. I'm not quite in that position, but maybe you are. Anyway, get in touch with Dan. There's lots of other good information at his website. Click on the button to the right. This is Marjorie Wildcraft, and you're with the Mother Earth News Online Homesteading Summit. We have a ton of other presentations just waiting for you. I'll catch you on the next one.